All right, welcome to week 4 of your lectures. Today we are going, this week, not today, we are going to talk about describing data, numerically. Hello, PowerPoint. Be helpful if you advanced. Thank you. So here's the lesson outline. We're going to talk about measures of center. We're going to talk about mean. We're going to talk about median. We're going to talk about mode. We're going to talk about mid-range. If you don't know how to calculate mean, median, or mode, you need to go back to the review videos all the way in the getting week one folder. Week 1. That'll tell you how to do that. I'm going to spend very little time on the mean, the median, and the mode. I'm going to talk a little bit about the mid-range. Then we're going to talk about measures of spread, which is range, standard deviation, and variability. We're going to talk about quartiles and percentiles and interquartile range and the 5-number summary and box plots. So let's get started. In this lesson, we're going to talk about 2 things called measures of center and measures of spread. Okay, these things go hand in hand together. The measure of center, mean, goes with the measure of spread, the standard deviation. The measure of center, median, goes with the quartiles. The mid-range goes with the range. You can't look at a standard deviation without a mean. You can't analyze the quartiles without the median, and you can't analyze the range without the mid-range. And let's talk about some notation. When we talk mean, we talk about a sample size or a population size, and that's either going to be small n or capital N. In this case, sample size is small n. X refers to a specific data value. Xi is the way we number the data values. I ranges from 1 to n, or the size of your sample size. This crazy symbol right here, this is called epsilon. It refers to summation. That means adding up values. So the sample mean, we give X bar. This is one of the most used symbols in stats. So remember X bar. And to calculate X bar, that's the mean, you add up all your data values and divide it by your sample size. Again, if you don't know how to do that, check the videos in week 1. Population mean is represented by mu. It's a Greek letter M, mu. Population size is a capital N, and to calculate that, we take the sum of our data values in the population over the size of the population. Now, the mean is very sensitive. Misplacement of a parenthesis, excuse that. The mean is very sensitive to extreme values. You can see that in the applet located on your student CD. I'll give you a video showing you how to get to that applet, and I'll show you how that applet works. If you have bigger data values up in the higher values, your mean gets pulled towards those higher values. If you have smaller data values, your mean is going to be pulled towards those smaller data values. And I will show you that again in another video. Measures of center is the median. We know the median is the middle. We know the median is not sensitive to extreme values because it is just the middle. Mode, the mode is the data value that appears most frequently. However, this can be misleading and is meaningless in small data sets. Mid-range. Mid-range is the average of the minimum and maximum value. So if I had oh, forget it. So it's, whoopsie. We have the minimum, the maximum. Ooh, that was bad. Excuse me. We have the minimum plus the maximum divided by 2, and that is your mid-range, okay? You need that when talking about range. Mid-range and range don't tell you a whole lot, and it ignores a lot about the data. What we are really going to be focusing on today is the percentiles, quartiles, and standard deviation and mean. So just keep mid-range in the back of your mind along with mode and range. All right, so when we're talking about skewness, if all the data values are high, the mean is going to be larger than the median. because the mean gets pulled towards the higher values. For a left skewed distribution, the median is going to be larger than the mean, or the mean is going to be smaller because the mean is pulled towards those lower values. And for a symmetric, it should pretty much all be right in the middle. So let me show you what I'm talking about. Here's a right skewed distribution, here's a left skewed distribution, and here's a symmetric distribution or a normal distribution. Okay. When we talk about standard deviation, we're really going to be talking about normal distributions. They're going to look like this. So let's quickly talk about the range. The range of a data set is the difference between the largest and smallest values in the data set. You know, range equals largest value minus smallest value. When we get it, we're going to get into standard deviation, and I know that I'm not going to have enough time to get this done in one video, so you're going to have to bear with me with several videos. All right, the standard deviation measures the data with respect to the center. In plain English, it's basically how the data varies on average compared to the mean. The first thing we need to do, though, is we need to look at something called a deviation, which is the difference between the data value and the mean of the data set. In a sample, the deviation is the data value minus the mean, or x bar. In a population, the deviation is the data value minus mu. So let's look at an example for deviation. We're going to calculate the deviations for Amanda and Bethany's delivery times. So first we need to calculate the mean. So I'm going to pause the video and get that done. All right, so Amanda's delivery times for her, let's use black, her x bar, actually this is going to be, we're going to consider this a population. So instead of x bar, we're going to want mu. My fault, my bad. So we want mu because we're going to consider this their population. So the mu for Amanda is 15. And Bethany's mu is actually also 15. Trying to make that look as much like a Greek letter as possible, but it's not working. All right, so now we're going to take the time subtracted, the mean subtracted by the time, or time subtracted by the mean, sorry. That matters because we need to have it right. So we're going to take 15 minus 15, which is 0. This one is -2. This one is -3, 0, -5. And just like magic, our entire chart is filled in. So again, I subtracted this minus this to get these deviations. Okay? When we calculate standard deviation, we're going to have to add all these up and have them squared, and we'll get there. All right, so now we're going to talk about population variance. Okay? That's sigma squared. Okay? This Greek letter here is called sigma. It's the mean of the squared deviations. So we're going to calculate the population variance for Amanda and Bethany, and remember, big N is going to equal 10 because they both had 10 deliveries. So we need to go back to this. We need to square these guys. So I should have left more room. So that's still 0. This is going to be 4, 9, 0, 25, and like magic, the squares of each of these appear. So now we need to add them up. So let's get that done. All right, so the sum for Amanda is 66 over 10. So she varies about 6.6 on her delivery times. And for Bethany, she is 704 divided by 10. So she varies about 70.4 for each of her data types. Now we're going to use these numbers to continue with this. All right, so the population standard deviation is actually the square root of both of these numbers. So for Amanda, her population standard deviation is the square root of 6.6, and that is equal to, what does the great almighty calculator say? that is 2.5690, or we'll just go with 2.57. And for Bethany, not so good. Her sigma is the square root of 70.4. So, well, and that comes out to 8.3905. So we could just say 8.39. So what does that mean? That means on average, okay, Amanda is pretty consistent. She only varies from her mean of delivery times by 2 minutes. I think it's in minutes. Let me check the text. Amanda, Bethany, where'd you go? Come back. I'm wasting time. Yep, on average, she varies about 2.57 minutes away from her mean. So she's very consistent. Bethany, on the other hand, varies about 8.39 minutes compared to her mean. So Amanda's the more consistent delivery girl. Now I'm going to show you how to do what we just did, and we're just going to do it to a sample. All right, so a sample standard deviation is indicated by this formula. Sample is the square root, or the sample standard deviation. Also, I abbreviate it as STD sometimes, is equal to the square root of the sum of the value minus the x bar squared. So the sum of all those squared over n minus 1, which is the sample size minus 1. I'm going to show you how to do it by hand once, but then there's going to be another video on how to calculate it in Excel. I highly suggest doing this in Excel because the arithmetic, you can get bogged down with the arithmetic, especially with larger data sets. All right, so here's an example on page 116. We're going to look through number 25 and 26. They ask us to find a whole bunch of stuff. I'm going to stop this video here, start a new video so I can really focus on just this example without a countdown mocking me. So stay tuned for another video.